And welcome back. Okay, so this time we're going to look at two topics, percentage yield and atom economy. So hopefully you should be able to calculate the percentage yield and the atom economy of a reaction. Now normally I try and focus on just one area per video. The reason I'm doing two is that people often get these two things confused and interchange them, think they're pretty much the same thing. I want to put both of them in a video to highlight the fact that they are different. Okay, they are separate processes. So before we start going through the specifics, I'd like you to think about why do reactions not go to completion? Now, I'm really focusing on industrial reactions here. Okay, so just pause the video, have a quick think. Why do you think reactions do not go to completion? Okay, done that? Great, hopefully you came up with a few reasons. Okay, so some reasons. Okay, so the first one is that the reaction might be reversible. Therefore, the reaction is never going to go to completion because it is always the competing backwards reaction. Now, potentially, all the chemicals, all the reactants might not have reacted. There could be a few reasons for this. Someone could have got stuck in the equipment during the different steps. The conditions might not have been perfect. They might not have been able to mix properly. All of these are reasons why you will not get the amount of product perhaps you thought you would. There may be competing reactions. So as you think A and B is making C and D, at the same time, you might also be making some E. If atoms are going into making E, they are not going into making C and D. Your reaction is not going to completion. Now, industries want to know how much product they're going to be getting for their money. They want to know how much product they are going to have to sell. So one thing they look at is percentage yield. Okay, so percentage yield is equal to actual yield divided by theoretical yield. Now, what do these actually mean? So the yield is basically the amount of product that you want. Okay, you might have more than one product, you might only want one of them. This is focused on the product you actually want from the reaction. So the actual yield is the amount of product you actually get. And the theoretical yield is the amount of product you could potentially have gotten if the reaction had gone perfectly, had gone to perfect completion. Okay, but in real life, in industry, you never get a perfect reaction. Okay, the highest you'll get, 99%, 99.5%, you will never get 100%. And then don't forget to turn it into a percentage by timesing by 100. Now, if you leave it as a decimal fraction, you probably will get away with it, but you should really turn it into a percentage. And one thing before we look at an example, I've said the amount of product. Now, this could potentially be moles, but it is normally mass. Okay? In your exam questions, you will normally be using mass of the product. So let's have a look at an example. Okay, when 60 decimeter cubed of hydrogen is reacted with excess nitrogen under high pressure and temperature in the presence of a catalyst, you should recognize this reaction, 25 decimeter cubed of ammonia was produced. It's asking you to work out the percentage yield. Okay, so this is the very famous Haber process used to get ammonia, which is a big component of fertilizers, also explosives. So how do we go about doing this? It's quite similar to calculations we've already looked at, okay? Especially the first step. Now, we've got information. Now, ammonia in this case is the only product, therefore it's the product we want as well. Now it says 25 decimeter cubed of ammonia was produced. This is the actual yield. Now we need to work out the theoretical yield. So how do we do this? Well, we start with one of the reactants, which is given. in this case hydrogen. So we have 60 decimeters cubed of hydrogen. Now notice that both the actual yield and the amount of chemical we've been given in this question is actually a volume. I've included this to show you that it doesn't have to be mass, okay? It just normally is. So we have this 60 decimeters cubed of a reactant. Now let's go through the steps we've seen in previous videos. So, first of all, you want to work out moles of hydrogen. How do we do this? Use one of the triangles you've already seen. So we need to divide the volume by the molar volume. Hopefully you remember molar volume is 24 decimeters cubed. Now this gives us 2.5 moles. Okay, next step. We need to convert this to moles of ammonia. Hopefully you can remember how to do this. You just use the molar ratio, which is 3 to 2. So divide by 3, multiply by 2. And that gives you 1 2/3 moles. But remember to keep the full number in your calculator for the next step. So to work out the theoretical yield, you need one more step, and that's to work out the volume of ammonia. So it's the number of moles multiplied by the molar volume, which gives you 40 decimeters cubed. Okay, so we've worked out theoretical yield. This is how much ammonia could have been produced if everything went perfectly. So we have our two values. Now if we go back to our equation for percentage yield, the actual yield divided by the theoretical yield times by 100, just stick in the numbers, you get 62.5%, which means that out of the potential amount of ammonia which could have been produced, you are producing 62.5%, which in industrial terms isn't actually that bad. Okay, so that is percentage yield. You normally are given the actual yield, and normally you have to work out the theoretical yield. You do that by using the same sort of steps we've already seen. Normally you'll be finding mass, but you don't have to. Could be moles, for this instance, volume. Okay, so that was percentage yield. Let's now look at atom economy. So atom economy is basically in a reaction. If it goes to completion, how many of the atoms which are going from the reactants actually going to form the product you want? That's basically it, okay? But you have a more technical formula. And the equation is that you take the mass of the desired product. By mass, I mean molecular mass or atomic mass, okay? So the mass of the desired product in the reaction divided by the sum of the masses of the products in the equation. Let's have a look at an example. So in this reaction here, we're asked to calculate the atom economy for the reaction that produces hydrogen for the Haber process. So we have natural gas, methane, added to hydrogen, which produces carbon dioxide and even more hydrogen. Okay, so let's go through this. Start by writing out the full equation again. So mass of the desired product in the reaction, and then divide by the sum of the masses of the products in the equation. So what is the mass of the desired product? So desired product is hydrogen. Okay, that's the whole point of this reaction. So it would be 4 lots the molecular mass of hydrogen divided by 1 times the molecular mass of carbon dioxide plus 4 times the molecular mass of hydrogen, which equals 4 times 2 divided by 1 times by 44 plus 4 times 2, which gives us 8 over 52 times by 100, obviously. Forgot to put those in. Which gives us the final answer of 15.4%. So that means out of the atoms in the reactants, if we look at it by mass of atom, only 15.4% will actually go into the desired product. This is a factor to consider for industrial processes. They want a high as possible atom economy because that reduces waste. Waste is bad for business. It costs money and they can't make any money from it. Okay? So they want as high an atom economy as possible. Now I'm going to go back to this reaction here just so that we can compare percentage yield we calculated just before and the atom economy for the reaction. Okay? So let's have a look at the atom economy for this reaction. I'm not going to write out the formula again, already done it twice, so you just have to look at the one in your notes. Okay? So for this, the mass of the desired product is ammonia. So it'd be 2 lots molecular mass of ammonia divided by 2 lots molecular mass of ammonia times by 100. So I'm not even going to write out the numbers. You should be able to see that because there is only one product, the atom economy is going to be 100%. Now, we've already seen that percentage yield, the one we worked out, is equal to 62.5%. And that percentage yield can change, depends on the conditions. Okay. The atom economy, however, will always be 100. They are totally separate processes. Percentage yield depends on the conditions, depends on the reaction proceeding well, all the reactants mixing together properly, if it's a reversible reaction being forced to the right-hand side. Atom economy, none of that matters. It's more a theoretical number of how much potential waste you could have from our reaction. In this case, we have an atom economy of 100. Percentage yield could be any number, just depends on the conditions. So they are totally separate processes. Lots of people don't get this. Hopefully, you now will. So hopefully, you can now write the equations for both percentage yield and atom economy and work them out in a question. And hopefully you'll be able to describe the differences between the two processes, because lots of people get confused and get them mixed up in the exam. Make sure that isn't you. Okay? So make sure you've completed your notes, and I'll see you in class.